Let's start talking specifics and details and get our hands dirty with some examples. However, before we can do anything with Azure, we need an account. There are two ways where you can start kicking the tires of Azure. The first is the introductory special. The introductory special can be found on the following website, but this account requires a credit card. So when you sign up, it's going to ask you several pieces of information, including address, name, location, and things like that, including a credit card. The introductory special gives you a certain amount of time of free Azure services. But after that time expires, your credit card starts getting billed. The second way, however, is the Windows Azure Platform 30-Day Pass. And it can be found at the windowsazurepass.com website. It's going to ask for a code, and so you can enter this code because this code is specific to the United States and North America. This is free for 30 days, requires no credit card, but does require a 2 to 3 day account creation process, so you won't be able to use that immediately. And the difference between this and the introductory special is that after 30 days, your account and all objects within your account will be deleted. So to create your account, open your browser and navigate to www.microsoft.com/Windows Azure/offers. And this will open up the Windows Azure offers page. When this page comes up, you'll notice that there are several offer options. You'll see the pay-as-you-go offers and the subscription offers, but the offer we want is right there in the middle of the page, called the Free Trial Introductory Special. It has many of the options that we want and is free for a certain number of months. So go ahead and click the Activate button, and it'll ask you to navigate and enter your Windows Live credentials. Signing up for a Windows Azure account is actually 4 steps. Step 1 is the contact information, so let's go ahead and fill out our contact information and then move on to step 2. Step 2 of the wizard is actually a summary of what you filled out on step 1, plus here you have to enter a subscription name for what your subscription account is going to be named. So let's fill in a subscription name and then go ahead and click Next. Step 3 of the wizard is the billing information. Remember, we discussed that this is going to ask you for a credit card information because it's going to start billing you after your free introductory trial is over. So go ahead and fill out your credit card information and your address and then click Next. Keep in mind that you can cancel this at any time. The last step of this wizard is asking you to read the terms and conditions. So go ahead and check the checkbox that you have read the agreement and then click Purchase. So congratulations, you just signed up for your Windows Azure account. A confirmation email will be sent to you, but here we're ready to start working with our Windows Azure platform subscriptions. So go ahead and click Finish. So clicking Finish will take you to the Windows Azure Platform Home Portal page, which looks like this. We're not going to be using this right now, but we'll be coming back to this page shortly. So for now, go ahead and minimize this page. So let's talk roles and instances. Roles are defined in a service model, and the service model defines the shape of a service, meaning it may define 1 or more roles per service. The roles it will have, currently you can define up to 5 roles per service, and the endpoints it will listen on, and the types of VMs that will be run. At runtime, each role will run at a given scale. Specifically, each role will be deployed onto and executed on 1 or more VMs as instances. Note that the slide says up to 20 per subscription, but if you need more than that, you can call in and get that limitation removed. A VM runs a single role as well. And a role instance is a set of code, configuration, and local data deployed in a dedicated virtual machine. There are 3 types of roles, and let's talk about those roles right now. There's a web role. A web role is a service component that is customized for web application programming as supported by Internet Information Services 7 and ASP.NET. The web role is intended to serve as the front end to your hosted service. Essentially, it is an application such as ASP.NET app configured to run in Windows Azure. You also have a worker role. This is a little different. It has no user interface. It is a service component that is useful for generalized development and may perform background processing for a web role. A worker role is frequently used for long-running tasks that are non-interactive, but you can host any type of workload. Think of a worker role as a Windows service. You also have a VM role. This is a special type of service component that offers the ability to fully control the operating system image of the virtual machine. The advantage of using a virtual machine role is the ability to easily update the operating system image and to directly install applications. Using a VM role, you can use Windows services, schedule tasks, you can configure and maintain the OS, and the primary difference between a web role and a worker role is the support for IIS. The web role is tooled to present an interface through IIS hosted websites and web application. In contrast, the worker role is flexible and open-ended. Most types of applications can be hosted in a worker role, including those that use non.NET languages or run unmanaged code. Some of the differences are that the web role provides supporting for presenting a user-facing front-end through IIS. While you can write code to present a user interface using a worker role, the web role makes creating this type of application easier. In the web role, IIS handles the efficiency of threading. In the worker role, you must handle threading issues yourself. You must also provide a run method that is called to initiate processing in a worker role. The security perimeter is different between the web and worker role. In the web role, the access control list for certificates are set to support IIS and network services by default. When using a worker role, you must set the ACLs to support the permissions your application requires. There are 3 types of roles available for computer nodes. A developer can use only web role instances, only worker role instances, or a combination of the two to create a Windows Azure application. If the application's load increases, he can use the Windows Azure portal to request more web role instances, more worker role instances, or more of both for his application. If the load decreases, he can reduce the number of running instances. To shut down the application completely, the developer can shut down all of the application's web role and worker role instances. Running applications with least privileges is widely regarded as an information security best practice. To align with the principle of least privilege, customers are not granted administrative access to their VMs, and customer software in Windows Azure is restricted to running under a low privilege account by itself. This reduces the potential impact and increases the necessary sophistication of any attack, requiring privilege elevation in addition to other exploits. It also protects the customer's service from attack by its own end users. Windows Azure also has a custom restricted privilege trust model available to all roles called Windows Azure Partial Trust. Based on customer demand, Windows Azure also supports full trust with native code execution. This option blocks execution of native non.NET code and not only minimizes the attack footprint of the role in question, but it also helps reduce damage caused by a compromised role. Based on customer demand, Windows Azure also supports full trust with native code execution. The developer can also bring their own virtual machine based on Windows Server 2008 R2, with whatever data is inside of it prepared on their own premise. The VM should be sysprepped, although that's not a hard requirement. The virtual machine role spins up the instance of this VM on deployment where customer specifies. The VM role must be patched by the customer using Windows Update or manually. This storage isn't persisted, however. When the instance is shut down, the VM and its local storage go away. Yet applications commonly need persistent storage that holds onto information even when they're not running. Meeting this need is the goal of the Windows Azure Storage Service. Virtualization is one of the driving technologies behind the ability of cloud services to scale up and down quickly relative to need. Virtualization also requires thoughtful management as formerly hard security boundaries between systems become virtualized and thus potentially subject to new attack vectors. In the Azure Compute Services nodes, the customer application runs inside virtual machines. Each virtual machine has 1, 2, 4, or 8 virtual CPUs and is allocated up to 14 gigabytes of memory. The virtual machines run a special version of Windows Server 2008 that has specific server operating system installed, IIS, .NET Framework, and other components as well, depending on the virtual machine role, and has a very limited number of device drivers. Customers do not have administrative privileges on the compute node virtual machines, and application code runs with least privileged Windows accounts. There is no persistent storage on the virtual machines, and each virtual machine is connected to 3 local virtual hard drives. Those hard drives are D, E, and C. The D drive contains one of several versions of Windows. Windows Azure provides the various images and keeps them up to date with respect to patches. The customer chooses the most appropriate version, and when there's a new version of Windows available, the customer can choose when to switch the VM over to it. The E drive image is provided by the customer and contains customer applications, and the C drive contains configuration information, paging file, and other storage. The Windows firewall is enabled on each virtual machine. The only ports open and addressable, internally and externally, on a virtual machine are those explicitly defined in the service destination file by the customer. Windows Azure uses its own hypervisor, a virtualization layer developed by Microsoft that is built on top of the lessons learned by Hyper-V. It runs directly over the hardware and divides a node into a variable number of virtual machines. Each node is also a root virtual machine, which runs the host operating system on hypervisor controlled systems. Azure uses a stripped-down version of Windows Server that includes only those components necessary to host VMs. This is done both to improve performance and to reduce attack surface. A critical boundary is the isolation of the root virtual machine from the guest virtual machines and the guest virtual machines from one another, managed by the hypervisor and the root OS. The hypervisor root operating system pairing leverages Microsoft's decade of operating system security experience, as well as more recent learning from Microsoft's Hyper-V to provide strong isolation of guest VMs. All access to network and disk by the virtual machines is mediated by the root OS. The hypervisor's virtual network switch filters all network traffic from and to the virtual machines and also prevents sniffer-based attacks against the virtual machines on the same physical host. Additional filters are in place to block broadcast and multicast traffic, with the exception of what is needed to maintain DHCP leases. All Windows Azure applications and all of the data in Windows Azure storage live in some Microsoft data center. Within that data center, the set of machines dedicated to Windows Azure is organized into a fabric. As the figure shows, the Windows Azure fabric consists of a large group of machines, all of which are managed by software called the Fabric Controller. The Fabric Controller is replicated across a group of 5 to 7 machines, and it owns all of the resources in the fabric, such as computers, switches, load balancers, and more. Because it can communicate with a Fabric agent on every computer, it's also aware of every Windows Azure application in the fabric. This broad knowledge lets the Fabric Controller do many useful things. It monitors all running applications, giving it an up-to-the-minute picture of what's happening in the fabric. It manages operating systems, taking care of things like patching the version of Windows Server 2008 that runs on Windows Azure VMs. It also decides where new applications should run, choosing physical servers to optimize hardware utilization or virtual machines. To do this, the Fabric Controller depends on a configuration file that is uploaded with each Windows Azure application. This file provides an XML-based description of what the application needs, such as how many web role instances, how many worker role instances, and more. Isolation between virtual machines does not depend on the security of Windows. It is enforced externally by the hypervisor, thus instead dependent on the security of the hypervisor and the exposed network and disk drivers, and the attack surface is minimized by accepting few commands and supporting only a few hardware devices. Core CPUs are also dedicated to particular VMs to avoid side-channel attacks, and guest disks are virtual hard drive files in the root OS's file. Hypervisor and root OS implement network packet filters to block spoof and unauthorized traffic to virtual machines as well. Customers manage applications and storage through a subscription. A subscription is created typically by associating new or existing credentials with a credit card number on the subscription portal website. Subsequent access to the subscription is controlled by a Windows Live ID. Windows Live ID is one of the longest-running Internet authentication services available and thus provides a rigorously tested gatekeeper for Windows Azure. Customers upload development applications and manage their hosted services and storage accounts through the Windows Azure portal, website, or programmatically through the Service Management API. Customers access the Windows Azure portal through a web browser or access Service Management API through standalone command line tools, either programmatically or using Visual Studio. The Service Management API is based on a user-generated public-private key pair and self-signed certificate registered through the Windows Azure portal. The certificate is then used to authenticate subsequent access to the Service Management API. The Service Management API queues requests to the Windows Azure Fabric, which then provisions, initializes, and manages the required application. Customers can monitor and manage their application via the portal or programmatically through the Service Management API using the same authentication mechanism. To increase the security of the Windows Azure Fabric, Fabric controllers are run in separate nodes than the compute or storage services. All communications between Windows Azure internal and components are protected with SSL. Communication from the Fabric controller to the managed nodes is unidirectional. So with that, let's talk about roles. There's roles, and well, roles. So let's dig into detail about the web role, the worker role, and the virtual machine role. And let's start with the web role. Typically, the web role is an ASPX page or a web service, but you can use other web development tools such as PHP to provide your services. An ASP.NET web role in Windows Azure is similar to an ASP.NET web application in that it is built with .aspx files and source code, but it also includes additional tools that allow it to run in the Windows Azure environment. A web role can also host most other applications that use the HTTP protocol, such as FastCGI or WCF service, by using the basic HTTP binding schema. One of the recent releases of Windows Azure allowed a web role to take full advantage of IIS by default. This means that one web role can run many websites, all hosted behind the same public IP address. This means you can have multiple sites, applications, virtual directories, and bindings that can be modeled, and everything else can be scripted using an admin access where necessary. So what are the role benefits? Among the few are lower cost of ownership, enhanced development agility, meaning that just with a few keystrokes you can upload your application to the Windows Azure portal and have it running in no time at all. So let's take a couple seconds and walk through the full IIS scenario with Windows Azure. Because Windows Azure is taking full IIS, you have local development options, and it's really easy and takes no time at all to publish and develop your Windows Azure application. You can use your local Visual Studio development environment to code and deploy your application. The first time you publish takes several minutes because it needs to deploy your service to Windows Azure. Just ensure that your Windows Azure service definition files are configured correctly to enable remote deployment and your instances. The iterative development process typically takes seconds because you can continue coding in the same Visual Studio solution and push intermittent changes via the web deploy method. And then finally, you can deploy your final version of your Windows Azure application to deploy your service to Windows Azure. So let's put some of this new knowledge to use about Windows Azure roles and create a new Windows Azure role project. So fire up a new instance of Microsoft Visual Studio. And when the start page comes up, let's create a new project. And you'll notice that because we installed the Windows Azure tools for Microsoft Visual Studio, that we have a new template installed called Cloud. And this allows us to create a new Windows Azure project. Let's go ahead and keep the name of our Windows Azure project to Windows Azure Project 1 and double-click on our Windows Azure project template. This also brings up now a new Windows Azure project dialog. And you'll notice in this dialog we can create several types of projects. We can create an ASP.NET web role, we can create a WCF service web role, and we can also create a worker role. For this example, we want to create an ASP.NET web role. So go ahead and double-click the ASP.NET web role, and let's change its name to Hello World. And then click OK. And you'll notice now that Visual Studio has created a new solution with two projects. There's our ASP.NET project, web project, And then we also have a new Windows Azure project. And you'll notice in our Windows Azure project that it contains a reference to our ASP.NET project, and it also contains a configuration file that defines the model for our Windows Azure solution, and we'll take a look at that in a minute. But what we want to do for this exercise is we want to modify our default .aspx page. So go ahead and click the Design button, and after the first line of code, click the Enter button to create a new line in our design page. And in our design page, we want to drop a label from our toolbox. So from our toolbox, let's select the label and drag it to our new line. We want to change our label to make it more visible, so go ahead and click the label. And then from our Properties window, let's change the font size to extra large. Now let's add a bit of code to display the text Hello Windows Azure in the label. So for this, right-click the design surface and select View Code from the context menu. And in the page load event, let's add the following. This.label1.text equals Hello Windows Azure. Let's save our changes. And let's go back to our Solution Explorer, because what we want to do is we want to change the number of instances that our application runs. So navigate over to the Solution Explorer and let's open the server's configuration file. And as you can see here, the configuration file defines the roles for our Windows Azure project and the number of instances that our role will run. And for this example, let's change the instance count from 1 to 2, and let's save our changes. Now let's start our application simply by right mouse clicking our Windows Azure project, and from the debug menu select Start New Instance. You'll notice now that you'll get an error. It simply states that to work with Windows Azure in your local environment, that you must run Visual Studio as an administrator. So go ahead and click OK, and let's close Microsoft Visual Studio. And let's go back to our icon and right mouse click the Microsoft Visual Studio icon and select Run as Administrator. You'll get the user account control asking you if it's okay to run this in elevated privileges, so go ahead and click Yes. And then from our list of projects, let's select our Windows Azure project. And there's all the changes that we made from our instance count. And let's run this again. However, before we run this, we need to initialize our local Windows Azure storage. And there are two ways we can do this. The first way is through the command line tool ds-init. The ds-init command line tool initializes our Windows Azure storage emulator in the local environment. Typically, this tool is run automatically the first time the storage emulator is started. If we were to run our project again, it would initialize our Windows Azure storage. However, if you installed SQL Server Express as part of your Visual Studio installation, your Windows Azure storage initialization might error. So what we want to do is we want to do this manually, because in this instance we have SQL Express installed. So we need to run the ds-init command line tool automatically to create and initialize our Windows Azure storage. So from the Start menu, let's open a command line. So type command, and let's open a command prompt. Now the ds-init command line tool is in the following directory. So we want to navigate to our program files directory, and within that the Windows Azure SDK directory, and with that we want to go to the version 1.4 of our SDK, and from there bin dev store. And you notice in there, if we do a directory, that there is our ds-init command line tool. So the way to initialize our Windows Azure storage in our local environment is to do the following. It is simply ds-init /SQL instance : and then we either specify the SQL instance in which we want to create the storage components, Or if we want to create them in our default instance, we simply specify the dot. So once you've typed that, go ahead and click Enter. Now again, you're going to get this prompt because it needs to run this in administrative privileges. So go ahead and click Yes. And what it's doing is it's creating several databases in your instance of SQL Server, changing some logins, creating some accounts, and doing everything it needs to do to initialize your Windows Azure storage. So we noticed by the information that our installation was successful and that our storage is now ready to use. So go ahead and click OK, and we're all done. So let's exit out of our command prompt, and now we're ready to run and test our web role. So go ahead and right mouse click again on our Windows Azure project, and from the debug menu select Start New Instance. And again, it's packaging the deployment, it's running the deployment, and it's initializing the Windows Azure Storage Emulator. And because we initialized it, it passed that. And running the deployment again, and in any second we should get a web browser page. There we go. So you've successfully run your first Windows Azure web role. And hello to Windows Azure. So we're done. We've just successfully created our first Windows Azure web role. So go ahead and click that. Well, before we close that though, however, I want to point out a couple things. You'll notice down in your taskbar a new icon. It looks like a little blue flag. If you right mouse click that, you'll be able to see, it'll bring up a context menu that shows and allows you to see several things. You can see the Compute Emulator user interface. You can see the Storage Emulator user interface. You can also shut both of those down if you wish. But what we want to do is we want to look at our Compute Emulator user interface. So select the Show Compute Emulator user interface. And this brings up the Windows Azure Compute Emulator dialog. Now you'll notice that it has the service deployments, and that under our deployment it lists two. So if we expand our Hello World node, you'll notice that it has two instances of our web role. There's web role 1 and web role 2. And they're zero-based, so it's hello world.0, hello world.1. You can select either one of these web roles and show the two instances that are running. So there's instance 1 and there's instance 2.